Hello everyone, welcome to this new video lecture on Introduction to Cloud Infrastructure, which is chapter 2. In this chapter, the following topics are covered. The essence of cloud infrastructure. Within this section, the following key points will be discussed. Core components of cloud infrastructure, service models, deployment models, benefits and challenges entitled to cloud infrastructure have been or will be presented. Then followed by section 2.1, historical evolution of data centers, data center components, design considerations for data centers, power calculations, and PUE for data centers, cloud management strategies, cloud software deployment considerations are covered in this lecture video. So to begin with the introduction or section 2.0, cloud infrastructure. So let's see the formal definition, what we mean by exactly cloud infrastructure. In general, we can see cloud infrastructure is a combination of hardware, software, network resources, and services in general that facilitates cloud computing. So that means that the cloud infrastructure is nothing else. It is an integration of several components of hardware, software, network resources, and services just to implement cloud computing. Having said that, the importance of cloud infrastructure is that it serves as a foundation for cloud-based services, providing scalable on-demand computing resources. So it is the backbone for cloud-based services in general, the cloud infrastructure. What it means exactly, we will enrich this concept piece by piece in the coming slides and next few slides, depending on their service models, deployment models, and the new emerging service models in the next few slides will be discussed. So the other key features or key concept in cloud infrastructure is that its components. What are the components that constitute the cloud infrastructure? The first one is that the servers and storage, meaning physical or virtual machines that process and store data. So these are nothing else. They are physical or virtual machines that process or help to process and store the data. The other key components of the cloud infrastructure is that the networking service, meaning high-speed communication between resources is one fundamental concept in realizing cloud infrastructure. The other also key feature is that, or component for realizing cloud infrastructure, is that virtualization. Virtualization is nothing else. It's a technology which helps or allows multiple virtual machines to run on a single physical server. Then we will see the detailed concepts and ideas associated to this virtualization technology in the coming slides or next few slides after we discuss some slides or few slides. Data center is another key component or core component in implementing or realization of cloud infrastructure, data center. So in this case, these data centers are nothing else. They are they help to ensure or secure facilities that house physical infrastructure. So that means that it's nothing else. Data centers in different literatures can be referred as a big buildings that hosts several computing devices or computers or machines for that matter to facilitate or secure facilities this cloud infrastructure as a key component. So to say more about these core components of cloud infrastructure is that let's see one by one these founding elements or foundational elements or components, what we mean by exactly and what do they constitute inside. So when we say the servers and storage, we have said it already at the beginning. Just they are physical servers that host applications and process data. Then there are also virtual servers that maximize or help to maximize efficiency by sharing resources. Furthermore, they also can serve as a storage includes such as HDDs, SSD, solid-state devices, hard disk devices, NAS, network attached storage, SAN, storage area network. The second one, which is the founding or core components of cloud infrastructure in realization of this service, in general, the cloud computing service, then networking is a must. Then this means that in case of networking, we are expecting high-speed routers and switches to ensure reliable connectivity. The other point is that firewalls and load balancers manage security and traffic respectively. This is very, very important in networking and in cloud computing services, as this cloud computing supports multi-tenant, meaning that multi-tenant model, meaning that multiple users can request multiple services, so that this cloud computing should have a feature that supports handling these several requests, and at the same time, since it is a multi-tenant environment, different people or cyber attacks could happen in between. So that means that these firewall and load balancers need to be in place to ensure the security and traffic. And of course, the services available on the cloud need load balancing. That means the traffics based on certain algorithms, it could be Robin algorithm or whatever any algorithm being implemented by the institution, will help us to allocate the loads and the traffic depending on the resources available in the cloud service providers. So this is very, 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 very important concept in realization of cloud infrastructure, at the same time the cloud computing service as a utility or as a service in general. And the other key and very important point, core component in realization of cloud infrastructure, thereby cloud computing, is virtualization. What we mean by virtualization, we will explain in its respective chapter or separate chapter 3, but still, since it is very, very important and it is not possible to realize the concept of cloud infrastructure, and even the chapter 1 that we did or we covered in the previous video lecture, so we have already touched at some level the concept of virtualization. Here again, we will repeat virtualization at some level, but still we will present it in a separate chapter. So the details associated to this virtualization technology will be presented. Until then, what we mean by virtualization. So this virtualization is nothing else. It's a technology that abstracts and transforms these various competing resources into virtual environment. That means it is mainly dedicated for optimization and utilization of resources. How? For example, from the virtualization, there is a concept called hypervisor, meaning this Hyper-V in short is known, so we can note from now onwards this hypervisor as Hyper-V, which is already installed in today's Windows operating system 10 and above, actually any version 10 and above, 11 and others, is supporting this internal structure of its system, the hypervisor. And there is another also, the Windows subsystem, Linux also could support this hypervisor in other way implementation. So what we mean by this hypervisor, such as the VMware, the Hyper-V can create or help to create virtual instances. And in other words, it enables better resource utilization and scalability, meaning that we can have or we can run multiple operating systems in a single local host machine in a virtual environment. So that means this is very possible through this virtualization technology, resource utilization and scalability. That means one can switch different operating systems from a local single machine and operates different operating system for different goals or purposes. This is what it means: resource utilization and scalability and efficiency. And the other component is that the core component for that matter is that the data centers. This is a huge building that constitutes different computing devices and machines for secure environments with power backup and cooling system. This is very important for realization of cloud infrastructure. And this data centers houses all critical cloud components, as I have said it already. So to say few more just key points on this virtualization concept, what we mean by this Hyper-V. This Hyper-V means it is nothing else. It is a software layer that manages and allocates physical resources to the virtual. What it means is that exactly, suppose that we have a host operating system. This host operating system it has its own storage disk and the processor or the CPU and the RAM. And then this guest operating system is able to run on this host operating system with the use of this Hyper-V technology such that we can enhance and utilize the resources of our host machine by creating a virtual resource or computer resources such as these virtual disks and virtual processors and virtual RAM. So this hypervisor is nothing else in general. It's a software or a technology for that matter that manages and allocates physical resources to the virtual machines. And what we mean by host machines and the guest operating system, the host machine is nothing else than the physical server running the hypervisor technology. And the guest operating system is nothing else the operating system running inside a virtual machine. So in this case, we can optimize the resources of different resources of a computer or a machine for that matter, so that we can enhance the services of the resources of our computer and thereby the cloud infrastructure, and thereby this is a very critical component in realization of cloud computing at the end. So the other key concept of this chapter is that the cloud service models. Of course, we have touched some points this in chapter 1. Regardless of that, it has its own key concept that we want to deliver it and this. So the cloud service models, as I have said, generally the cloud computing cloud can be classified as a service model and deployment model. Okay, deployment model. So what we mean by this cloud service model, these services can be arranged in a form of the type of computing services that the service provider could provide or could manage for that matter, and the client that can manage or could receive. So in this case, infrastructure as a service, which is IaaS, which means it provides virtualization or virtualized resources or environments such as compute, storage, and networking. Meaning, the typical examples for the infrastructure service is that AWS, the Azure, the Amazon Web Services, which is the EC2, means the Elastic Compute Cloud. That is the short form of that, EC2. Then the Google Compute Engine. So these services are possible nowadays sees the establishment of the cloud computing as infrastructure as a service. And the other thing, the platform as a service, meaning the PaaS in short, offers an environment for developing and deploying applications without managing infrastructure. You see, in this case, this platform simply, it's very good to recall that layer so that in this case, those software developers or application developers can handle only application plus data. Then, in such scenario, the rest layers of the competing services or competing cloud services will be taken care of by the service provider, and these are the only that we want to enhance our algorithm, the source code, efficiency of the code, maybe time complexity, space complexity, and the data processing, the arrangement of the data, whatever the data processing techniques that run with this application. Then in such scenario, we need platform as a service, not infrastructure as a service. And the other one is very important idea, the cloud service model, is that the software as a service, that is SaaS in short, meaning it delivers fully packaged or functional software over the internet, such as the Google Workspace, Microsoft 365, the Dropbox, even Google Docs and other things. Okay, that means almost it is all things that could be used as installation, and you run it without taking care of any management issues and concern. So we refer that service as cloud service model. We refer that specifically as SaaS, okay, which is software as a service. Then to give more demonstration in our discussion regarding this cloud service models, this is one aspect, well-known service provider, cloud computing service provider, which is called the Microsoft. Then that is the cloud service for under the Microsoft is Microsoft Azure Cloud Computing Services. Now, someone can recall the 5 or 6 elements definition of NIST regarding the cloud computing, and then like the Microsoft by itself. So that means that anybody can access this cloud computing as long as you have a network devices or any IoT devices, so that you could fail on the range of any network, then you could manage or utilize these resources without interruption, without intervention of the cloud service provider or any other else third party. So you can see on the left side, you can create a resource. That means if the user need or the customer need can utilize any form of services available by the Microsoft Azure, such as storage accounts and virtual machines, then the group resource groups, you can group. This is for the management purpose, and this is now the service models arrangement based on the type of services you demand. Then you can get the service model, or the payment modality. Okay. Then we have another container applications or apps. We have this help and support, the disks, and another disks availability here, which is the disk accesses. And then you can request another more services in case you need. So what it is exactly this, it tells us you have another here, virtual machines. You need, for example, you need 10 machines, virtual machines. You can run those virtual machines on your local server or on your local machine without worrying about what type of server, what type of bandwidth is, what type of memory space, or how much memory space or RAM or disks could run on that machine. That's none of the customer's concern. That is already to be taken care of by the third party, in this case, the service provider, the cloud service provider, the CSP. So thank you to this interesting service and really important service. Okay, and then you can see another service, which is SQL databases, and then you have Azure Cosmos database, and you have load balancers here, storage accounts here, resource groups, and of course you can also see what's going on using the dashboard activities. So this is all about the cloud services, cloud computing services offered from Microsoft Azure. That's the important concept. And the other key ideas that to be presented here in this PPT, that the component classifications of cloud computing. What means is that we have seen already the core components, but we need to very formalize our definition in such a way that in terms of hardware components, software components, and so forth. So that means in terms of hardware components, the server, the storage systems, the networking equipment will fall on this category. That means the servers represented as boxes or racks for that matter. Those are the physical machines that process data. And the storage systems are shown as disks or arrays. Those store data. As I have said it here, these are the arrays of disk, you see. Then in storage system, then in networking equipment, different computing services or devices we have, resources we have in general, such as routers, switches, and cables facilitate communication. So that means in general, when we are talking about networking, so all the networking resources associated in implementing network is available. And the other point is that software components, which means that the virtualization technology we have mentioned in the above, now it belongs to the software components, and the management tools such as the manage and monitor the cloud environment, which is fall to the software components group. Therefore, this virtualization software is nothing else. It's a technology that abstracts hardware resources, allowing multiple virtual machines to run on a single physical server. We have said it already. Then the other thing is network infrastructure, meaning we have internet connection and the client devices to be categorized in this category, and then it is a cloud icon or a globe can represent the internet connection. So of course this cloud computing, as we have said, based on the NIST and Microsoft, even in chapter 1, the network is the most important requirement in realization of this cloud computing service. So it is classified as network infrastructure. And the other thing is that as long as you have devices that could satisfy network device, then laptops, tablets, or smartphones accessing cloud services is possible. And the other key concept is the cloud service models. We have said it already. Then this classification is mostly supported by different literatures, but the recent technology also adds, there is a concept called PaaS, which is the function as a service or just simply serverless computing service. So is classified in this group, which is called cloud service models. So this IaaS is nothing else. It is virtualized computing resources, meaning all computing services such as the network, the database, and the storage, and the servers up to the virtualization is being classified under IaaS. Then in case of PaaS, that's development environment, meaning the application and the data is being taken care of or be in charge of by the customer, not by the service provider. That means the service provider will in charge or just taking care of or manage in short those layers down to application and data, meaning all this runtime, the middleware runtime, the middleware, the operating system, virtualization, the server, the storage, the networking are to be managed by the service provider. So the last one, deployment models, which is in this case we have public, private, hybrid. We have said it already. In public, shared resources accessible via the internet. In case of private, dedicated. This is a very important feature. That means dedicated resources behind a firewall. You see, unlike in public, which there is no any requirement for isolation or for firewall in between. But in case of private, we can this is mostly dedicated for resources behind a firewall, meaning if there is classified informations, the so-called sensitive data, for example, or whatever resources from the organization or from individual for that matter, then that's what we are exactly referring to. That service is called private cloud. They are to be placed on that private cloud. And then in case there is a need to divide your assets, organizational assets like It could be any data or information. Then to put some of them classified data on private and the other data non-classified on public, then that means the possibility of combination of public and private cloud is so-called a hybrid. So let's see what is the cloud computing architecture at high level. That means the layers and the components, or the interaction of systems or subsystems within that interaction of components within the bigger system, so-called the cloud computing. So you can see now at the edge, you can see there are devices, laptops, phones, tablets, desktops, and servers. These are nothing else. These are the computing devices, or just simply they are something devices that could help us to get access the cloud computing, as long as they are networked devices. Then they can access through the internet that cloud service. So this is the one key concept of this architecture. And the other thing, within this cloud computing, we can create 3 major layers. That means we have an application layer, and we have a platform layer, and we have infrastructure layer. So this infrastructure layer is nothing else. It provides virtualization or virtualized resources such as the network and block storage or storage, whatever, and other compute services. When it comes to platform, this also offers the services from this, just the infrastructure, plus the other services such as the middleware, the run system, and the operating system. So in that case, mostly this is used by the developers, software engineers that who are dedicated only to manage their application and associated data. Then in this case, you can see there are identity. Then this is possible to check this identity of the user while someone logs onto the cloud computing services, or on a demand to access that cloud computing service. And the last layer is that is the application, where it is mostly constituted services such as monitoring, content, collaboration, communication, and finance. So that means these are now services that are available and managed most its facilities as an application. So you can see this one is another high level, which already a mimic of this one in other way around. That means we have a front end, which is at the end from the client, and at the back end, which is now the hidden to the client. Then we have now in between, which is very important feature, that is internet. So we have application, we have services and storage, and we have another management and the security. So this can be depicted as back end, and this can be depicted the other end as a front end. That is the client infrastructure, and this is almost the back end infrastructure. So both describe the ideas in different representation. So totally the idea that we have seen in these two images, or whatever figures you can call them, visually represents the cloud computing architecture by categorizing its components into 3 main layers. So we have said it already briefly, even in detail. The infrastructure service or layer is all about the foundation of cloud computing, providing core resources such as compute, block storage, and network. That's what exactly I said, this one. And then the platform layer, which is layer 2, provides development and deployment services such as object storage, identity, runtime, queue, database. The database is there for data management and storage solutions. The queue is there for managing queues, for message queues for asynchronous communication, and runtime execution environment for applications. Identity, just this is to make sure that authorized users are only allowed to access computing, the cloud services or computing services, whatever the services they require, there has to be a mechanism to check the identity access management. So there are different services to check and to ensure this security. And the object storage, such as scalable storage devices, scalable storage for files and data, is being viewed as a layer in layer 2, which is platform layer. You can see this idea on this one. Okay, the object is here, the object storage, the identity, the runtime, and the queue, and the database, which is the platform layer, layer 2. The layer 3, which is the application layer, which is the end layer, includes cloud-based services used by business and individuals. You see, this is called the client end. In the second graph, the second image, this is now why we call it front end, which is mostly the application. That means it's all about tracking system performance, media and data management, tools for teamwork and remote work, email messaging, VoIP. This is a type of internet that supports audio communication, and of course video communication is voice communication, and then messaging, different apps, and then the emailing. So this is in general the communication. And the finance, that cloud-based financial management systems, the collaboration tools for teamwork and remote work, such as the Slack, whatever tools that could help in the development time. And then the content, which is the media and data management, and monitoring, which is the tracking system performance. So this is consistently aligned with the definition of the two popular approaches, so-called the NIST and Microsoft, that they tell us the cloud computing is nothing else that supports the communication of the clients, the end user, just simply through the internet. That is what they said among the key features. You can revise or refresh your knowledge related to these operational definitions for cloud computing given by these two popular and well-known organizations, or company for that matter. So the cloud access devices, as I have said, you can see those who are at the edge, this one, the servers, these are called the cloud access device, meaning they are cloud services can be accessed from various devices, including laptop, desktop, phones, tablets, and servers. Not necessarily the list is the last. Now, coming to the benefits of cloud infrastructure, well, it's obviously by now scalability and flexibility is one big gain. Big gain from cloud computing and cloud infrastructure features. That means resources can be scaled up or down as needed. We have said this even in chapter 1 lecture video. The idea, scalability and flexibility, is very possible just based on on-demand self-service. Okay, that means you can scale up or down resources. That is the key feature of scalability and flexibility. And the other thing is cost efficiency, because do you know why? You pay for the size. That means pay as you go. Pricing eliminates large capital expenditures. Okay. In the case of on-premises, for example, if you need to store or process just one application or one program that requires 2 RAM, and then, but you may buy 10 GB. Then the 8 GB necessarily not used. But in the case of cloud computing, still you can release or order on demand. That is what it makes it. Simply you pay based on the service you utilize. Then the other one is accessibility, meaning users can access cloud resources from anywhere. That is the ubiquitous characteristics or feature of technology. And the other one is disaster recovery and business continuity. Of course, data redundancy ensures resilience against failures. That means in case of the cloud infrastructure, if you use either of these services, okay, based on these cloud service providers, obviously data disaster recovery or data loss is less in comparison to the on-premises model. This is obviously we have spent ample amount of time to internalize and to clarify this concept in chapter 1 as well, and we have said it so again here. So the other here important lesson is that challenges in cloud infrastructure. What we mean by the challenge, still despite these advantages we mentioned, still the cloud infrastructure is being questioned or cautioned, like the security and compliance, meaning managing data protection in a multi-tenant environment is not an easy task. That means since this cloud infrastructure allows multi-tenant environments, so at a time from all over the world, multiple users could request or send requests to utilize different resources available on the cloud. So that means all multi-tenant environments, in between there could be malicious acts. So that is now there is a probability of exposing the cloud service or even the user service could be interrupted. That is attacks such as man in the middle and other cyber attacks in general. Even the DOS and another DNS. So there are different cyber attacks and phishing could happen. So for this scenario, the security and compliance is very, very important feature for the continuity of cloud computing. So this is one challenge to make or to ensure the service is available in a secure fashion. And of course, in alignment to the compliance. What we mean compliance is there are some standardization for security and ethics, then such as the HIPAA and GDPR. We will see those things on the coming slide. So management and management complexity, that's very clear. That means in cloud infrastructure, the service deployment and service models we have said are possible, like public, private, and hybrid, community, and other things. So even though hybrid and multi-cloud is an advantage or as an important feature, still it is orchestrating its own scenario or challenge. That means hybrid means, in this case, you are allowing someone to use the combination of public and private or just different another services of different companies. So the issue of interoperability for the company and individual is not a simple idea. It is really complex to manage such architecture in reality, in practice. So the other key challenge that need to be addressed or need to be recognized is that the latency and performance issue. Latency is referring to the time efficiency. So that means this cloud infrastructure, there has to be a concern of geographic distance and network conditions. Obviously, they are inversely related. That means the geographic distance and network conditions obviously affect our competing services and affect the speed. So what we mean by these challenges in general, cloud infrastructure is obviously prone to several critical challenges that affect security, management, and performance. These are generally the impact from the challenge that could be driven. So the first one is security and compliance. What it means that in a situation where multi-tenant environment is exposed, while the cloud providers host multiple users on shared infrastructure, meaning there is a chance or a likelihood of increasing the risk of unauthorized access or data breach is possible. So this is one challenge. And the other challenge is that data protection and privacy, which is a key feature to be ensured by the cloud service providers. That is what the customers dictate, obviously, in real life. So we need privacy and we need our data to be protected. However, in such scenario, organizations must ensure that the sensitive information is encrypted, backed up, compliant with the regulatory frameworks such as GDPR, HIPAA, and ISO. So these ideas, you can review and refresh your understanding on separate notes or different resources in order to understand what these regulatory and compliance frameworks are exactly saying. So all in all, this is what the rules the organization must, in accordance to ensure data protection and privacy of its customers. Through cryptography and other things, there are different algorithms here to be applied. And the other thing is access control and authentication. That means implementing maybe multi-factor authentication, MFA in short, and role-based access control. That means you allow access based on their role, essential to prevent unauthorized access. So this is now a challenge in cloud infrastructure and cloud computing at the end. So the other challenge is that the management complexity, meaning hybrid and multi-cloud orchestration. That means the integration of these different services, multi-cloud, meaning that someone can use AWS Lambda function from AWS company or a service provider, and someone can use Microsoft Azure storage, and someone can use SaaS from another one. Therefore, the possibility of multi-cloud, it is the beauty of cloud computing, and the other side of a coin is becoming a challenge. Because in case of hybrid and multi-cloud orchestration, well, organizations often use a combination of public, private, and hybrid cloud solutions, but this requires advanced tools for integration and automation. So integration of independent system is not an easy task. So this is, of course, what we mean by the challenge. And the other thing is scalability and resource allocation means that dynamic workload management and ensuring optimal resource utilization across cloud platforms can be challenging. So the scalability is one challenge. And cost optimization and controlled resource provisioning can lead to high operational costs, requiring effective monitoring and cost management strategies. So in this case, in order to avoid uncontrolled resource, so the organizations or service providers are required to apply effective monitoring and cost management strategies. So this is one way, one challenge in realizing the cloud computing service. And the other key point is that latency and performance issue, meaning the geographic distance, as I have said, data centers located far from the users introduce latency, meaning that affecting real-time applications such as video conferencing, online gaming, and financial transactions. And the other is the network conditions or congestion. High traffic loads can slow down data transfer. That's why the load balancer is also a key technology enabler in realizing cloud infrastructure, which we have mentioned it in the beginning, in the on the high level architecture, in the two graphs above we discussed. So impacting cloud-based services and enterprise applications. And the other thing is content delivery and edge computing, which means solutions such as CDNs, in short, content delivery networks, and edge computing help reduce latency by caching and processing data closer to the end user. So that means the edge computing is an advantage in realizing or in reducing latency, because it helps to process whatever the data and other services near or just closer to the source. So reducing latency is a key feature. However, again, in such scenario, the edge computing can store or cache and process data closer to end users. So these are the general challenges that we have mentioned in detail regarding the cloud infrastructure, in implementing cloud infrastructure to realize cloud computing, such that the security and compliance and the management complexity due to the allowance of hybrid and multi-cloud different deployment models cloud models, and latency and performance issues are also the arrangement and the distance or the geographic arrangement of these data centers could affect our real-time applications related to video conferencing, online gaming, or whatever financial transactions. Those applications require real-time and real response could be affected because of these geographic and other network conditions and congestion and other due to the high-level complexity that could come up from the architecture by itself, the deployment model, the allowance of multi-cloud, community, and hybrid. That is in general the idea behind the challenge. So thank you for this lesson.